The world is facing a major challenge, the overpopulation. With more people comes a greater demand for resources, more waste, and a growing strain on our environment. The Philippines is no stranger to this issue. Our growing population has led to significant environmental challenges, especially in waste management. Iverson G. Garcia, Project Leader, Document Analyst, and Quality Assurance. Choco L. Borromeo, Document Analyst and Quality Assurance. Charles P. Cabrera, Document Analyst, Quality Assurance and Video Editor. John Rendell P. Manaloto, Assistant Programmer and Mobile App Developer. Manuel Rafael D. Tolentino, Main Programmer, Document Analyst and Quality Assurance. Enter BINhi, a revolutionary reverse vending machine that's changing the way we think about waste. The name BINhi is a beautiful nod to the Filipino language, meaning seed. This machine can help us shape a more sustainable future. The Arduino Mega 2560 is used to control and manage various components in complex projects. It acts as the central controller that processes input from sensors, controls outputs like motors or LEDs, and communicates with other devices, making it ideal for projects that require handling multiple tasks simultaneously, such as robotics, automation, or IoT systems. A microswitch is used to detect physical states, such as pressing or activating a button. It sends a signal to the microcontroller, triggering actions like turning on devices or sending data to a system. The ESP8266 is a low-cost Wi-Fi module commonly used in IoT projects to enable wireless communication. It receives data from the Arduino Mega, which sends information through serial communication, and then transmits it over a Wi-Fi network to cloud services, other devices, or a web server, allowing for remote control and monitoring of the system. The relay is used to control the activation of the buzzer. When the Arduino Mega sends a control signal, the relay switches on, allowing current to flow and activating the buzzer, which can then provide an audible alert or notification. The stepper motor is used in the seed dispenser to control the precise amount of seeds dispensed. It ensures accurate and consistent movement, allowing the dispenser to release the correct number of seeds each time. The ultrasonic sensor is used to detect the presence of materials at the entrance and exit, triggering the activation of the servo motor. It also measures the level of the bin, helping determine whether it is full or needs to be emptied. A 12V 5A DC power supply provides a stable 12-volt direct current DC output with a maximum current of 5 amps. It is used to power devices and components in our project that require a higher power load, such as motors, relays, or the Arduino Mega, ensuring they receive consistent and sufficient power to function properly. 3 DC-DC buck converters are used to step down the 12V power supply to different lower voltages, 5V, 7V, and 9V. This ensures that components like the Arduino Mega, sensors, and motors receive the correct voltage for optimal performance and safety. In total, 3 MG996 or servo motors are used in our project, one at the entrance, one at the exit, and one for the segregation process, ensuring precise control and movement of materials throughout the system. The 5 kg load cell is used to measure the weight of the heavy materials being inserted into the system. It ensures accurate detection of heavier items, helping the system properly handle and process materials based on their weight. In our project, we use 7 push buttons for different functions, 1 for finishing the process, 1 for donating, 4 for dispensing seeds, 1 to 4, and 1 for manual opening. Each button sends a signal to the microcontroller to trigger the corresponding action, providing easy control over the system's operations. The 20x4 LCD with I2C is used in your project to display important information, such as the points accumulated and the current status of the machine. This allows users to easily monitor the system's progress and functionality in real time. The buzzer in our project is triggered when the door is open, providing an audible alert to notify users that the door has been accessed or that the system is in an active state. This ensures immediate awareness and helps maintain proper operation. Inductive, capacitive, and IR sensors detect environmental changes. Inductive sensors detect metal objects through electromagnetic fields. Capacitive sensors sense changes in capacitance, detecting materials like liquids and plastics. IR sensors use infrared light to detect objects or measure distance, either by emitting and receiving light or detecting infrared radiation. These sensors are widely used in industries, touchscreens, and motion detection. The user first needs to point to the material they want to insert. Once the material is detected, the system will display the type of material on the LCD screen. The system has a sorting function where it automatically decides which bin the material falls into, the plastic bin, metal bin, or the rejected items bin. The system sorts materials such as metal cans, plastic, and paper, ensuring that each type of material is properly segregated. If the user inserts an invalid material, such as a plastic bottle with water inside, the machine will automatically return it. The LCD screen will display a message indicating that the material is invalid. If the metal bin is full, the user will not be able to insert metal cans, but they can still insert plastic bottles. Similarly, if the plastic bin is full, the user can still insert metal cans, but not plastic bottles. The system will return any invalid items to the return item bin and display the status on the LCD screen. When the bins are full and the staff collects or empties them, they can press the micro switch to reset the system. The LCD screen will display a message confirming that the materials have been collected, allowing the system to resume normal operation for user input. To proceed to the reward section, the user must press the finish button. Each seed dispensed is worth a certain number of points, 10, 15, 20, or 25 points. If the user's points are not enough to proceed with the reward, the system will display a message saying, "Not enough points, please insert more materials." However, if the user has remaining points that are insufficient for any seed, but still has recyclable materials, they can continue inserting the materials into the system to accumulate more points. User has remaining points, they can choose to donate those points by pressing the donate button, contributing them to a cause or charity of their choice. The seed dispenser has a rotation limit of 10, and the staff or owner can press the corresponding micro switch to reset it. With 4 stepper motors and 4 micro switches, each reset will be displayed on the LCD screen, showing which dispenser was reset. The user cannot insert any items if the door is opened. The buzzer will sound, and the LCD screen will display a message indicating that the door is open, preventing further item insertion until the door is closed. In the mobile app, the owner or system manager can easily monitor the status of the plastic and metal bins, receiving real-time notifications when either of the bins is full. This feature helps ensure efficient management of the system by notifying the user when it's time to empty the bins and prevent overflow. In the mobile app, the owner or system manager can also view the number of items inserted by users, along with the type of material, plastic or metal cans. This provides real-time tracking of the materials being processed by the system. The researchers chose certain SDGs around which the study would revolve. The study attempted to target the following Sustainable Development Goals. The BINhi project supports SDG 4.4 by equipping youth and adults with technical skills in waste management and operating reverse vending machines. This helps develop vocational skills that lead to employment and entrepreneurship, promoting sustainable practices and economic growth. The BINhi project supports SDG 9 by promoting domestic technology innovation through reverse vending machines and IoT systems. It also enhances access to information and communication technologies, contributing to affordable internet access and fostering innovation in the community. The BINhi project supports SDG 11 by fostering economic, social, and environmental connections between urban, peri-urban, and rural areas. By promoting sustainable waste management and technology use, it strengthens the ties between communities, encouraging collaboration and shared growth. The BINhi project supports SDG 12 by promoting efficient recycling, sustainable waste management, and reducing waste through prevention, recycling, and reuse, contributing to the responsible use of natural resources and environmentally sound waste handling. The BINhi project supports SDG 13.3 by raising awareness on climate change through education on recycling and sustainable waste management. It enhances community capacity to contribute to climate change mitigation and adaptation, promoting environmental responsibility and proactive action. The RPM project uses C++ programming on the Arduino IDE platform to promote recycling and sustainability, integrating hardware components like sensors, actuators, and communication modules to ensure functionality and effectiveness. The project incorporates tools like Arduino IDE, Canva, BINhi, Circuit Designer, and Blender to support hardware development, circuit design, 3D modeling, and mobile app creation, improving both functionality and user experience. The development began with analyzing functional requirements, creating a prototype, and conducting alpha and beta testing to refine the system based on internal and external feedback. After successful testing, the system was deployed in Barangay Mamatitang, where real-world evaluation and user feedback led to improvements in hardware, software, and user interface design. The system continues to evolve post-deployment with ongoing updates and a maintenance plan to ensure long-term functionality and reliability, addressing user needs and advancing environmental sustainability. The flowchart illustrates the reverse vending machine process, where users insert materials that are assessed for acceptance based on type and condition. Accepted materials are categorized into plastic or metal, points are awarded, and users can either redeem rewards like seeds or exit the system, while rejected materials are returned. The circuit diagram shows the connections and components of the reverse vending machine, highlighting how sensors, actuators, and controllers work together to process materials and dispense rewards efficiently. The BINhi, seed engagement of Barangay Mamatitang through reverse vending machine promotes waste management and community engagement towards sustainability. Alpha and beta testing showed effective segregation of plastic bottles and metal cans, despite limitations like undetectable materials and size measurement features. Future upgrades to enhance detection and expand capabilities are recommended, with potential to scale the project to other communities for greater impact. We sincerely thank Mabalacat City College and the Institute of Business and Computing Education for their support and guidance in making this project possible.